and a YouTube. This is a video about the extruder I am building for my 3D printer. Now there's a couple of other earlier videos about it on my channel. Basically what's different about this extruder is that it is powered by a DC servo motor rather than a stepper motor, and the reason for that is that a DC servo motor is very much lighter than a stepper motor, and you can therefore get the head to move back and forwards faster, because there's less mass to move around. So here we are. This is what I made. Now the first thing you can see is that it is a horrible mess. There's a reason for this. When I was designing this whole thing, my original idea was to have all the electronics off somewhere else in a box, not mounted on here to reduce the weight and for various other reasons. Unfortunately, it became apparent halfway through building the thing that really wasn't going to work. I'm using a thermocouple to sense the temperature rather than a thermistor, and the signals from a thermocouple are really small. They're really low voltage, and running them along a cable and through connectors right next to really high power PWM control lines and power lines just wasn't going to work. So I had to put the temperature controller and the drive for the heater into this area here, and there wasn't really room for it because it was never designed in when I did the mechanics. So yeah, that's kind of annoying, but I think I've got it working now. So we have a very much overkill servo motor here with a built-in gear head and a built-in encoder. That just goes straight off to the PID controller that you can see in one of my previous videos, which we mounted in the control box. So we've got a heater cartridge in the hot end here, which plugs into here. There's a MOSFET to control that. There's a little Arduino Pro Mini here which deals with controlling the temperature with a little PID loop, and all this other stuff is really just to get the connections in the right place. There's a thermocouple interface chip here which does all the funky stuff for compensation with thermocouples and cold points and all that kind of business, which I didn't really fancy getting into, and it just gives a nice voltage output. So that goes into the analog input of the Arduino here. The filament goes in through this connector here, and into the extruder assembly. So if I turn this around, you can get a better idea of the mechanics. Filament comes in here, goes along there, goes into this block here. This wheel is knurled, and this is the lever tension bar which pinches down onto it, and then it goes out the front. Let's zoom in on this if we can. I'll focus on it. So the actual hot end, I've soldered the thermocouple onto the hot end with high temperature solder. You do have to use high temperature solder. Low standard electronic solder will actually melt at the temperatures that these operate at. Even for extruding PLA, it'll melt. So yep, that's soldered on with high temperature solder, so there'll be a really good thermal contact there. This whole block is machined from a solid bit of copper, so there's really good thermal transfer from the heating element to the filament. The joining bit there is just a little machine bit of stainless steel. One thing I've discovered in my previous attempts to build an extruder is that you don't actually have to bother too much about sealing in the hot end. So there isn't any glue or seal between these two things. The only thing that stops the molten filament squirting out is friction. Basically, it's thick, it's viscous, and if you machine both sides completely flat and just screw them against each other, that's perfectly good. There'll be no leakage there. That saves all sorts of mucking about with threads and sealing things and O-rings and all the other kind of things that a lot of other extruders you see have, and it's not really necessary in my opinion. So yeah, there we go. This whole thing has been designed mechanically to have easy access to the filament. So if something goes wrong, it's really easy to sort it out, to sort it out quickly. My previous extruder, it was the way it was all bolted together. If something got jammed up, you had to take the entire thing apart to fix it, and that was really annoying. So yeah, hence this design. This whole section is empty in case I want to add a second extruder here for, you know, something else, a different sort of filament or paste or, you know, whatever. So yeah, there we go. A strain relief here. The wire is actually pretty stiff. It doesn't bend very easily, so I didn't think it needed a very flexible strain relief. So that's just a bit of machined aluminium epoxied into this sort of bulkhead here. So yeah, there we go. I hope that was vaguely useful for anyone building their own 3D printer. The next stage is the control box, which is fairly involved. It has a whole load of DSP based stepper motor and servo motor controllers, and a mini ITX board to control it all, so that will be the subject of my next 3D printer video. So yeah, I hope you found that interesting, and come again.